Alright, video 6.6, we're talking about molecular formulas here, so let's get started. Alright, on video 6.5 you learned about what an empirical formula was. If you remember, that's the lowest whole number ratio for a formula. And we even define molecular formulas as the formulas we've been writing pretty much all year long. So if you're talking about, a reminder, if we're talking about like C2, H6, which is ethane. Alright, this is the molecular formula. Alright, this is the molecular formula. And if you remember, the empirical formula is reduced. So this is a 2 to 6 ratio that can be reduced if you divide them both by 2 to CH3. And there we go. What we have here is the empirical. Alright. And in the last video I showed you how to calculate empirical. We now are going to figure out how to do the molecular, the real formula for it. So there's our periodic table. We'll pop back and forth, and here we go. Alright, an unknown sugar is found to have a formula mass. Alright, another name for formula mass is molecular mass. So it's a molecular mass or formula mass of 180.1 grams per mole. The sugar contains 40.0% carbon, 6.7% hydrogen, 53.3% oxygen. Find the empirical molecular formulas. Okay, first thing we're going to do, we're going to find the empirical again. So if you don't remember how to do that or want some more practice, here we go. So first thing, take your percentages and put them to grams. 40.0 grams of carbon. For hydrogen, we have 6.7 grams. And for oxygen, we have 53.3 grams. There's your first thing. Next thing, we want to convert from grams to moles of each of these. We want to convert from grams to moles of every single one of your elements. Alright, gram and mole together. My mole is 1. My grams, I go to the periodic table. Alright, for the first one up here, we have carbon. It's 12.0. So, 12.0 grams. Alright, for hydrogen, I've got for every 1 mole, periodic table, hydrogen is 1.0. So, 1.0 grams go there. And for the last one, we have oxygen. I've got 1 mole here. Go to our periodic table for grams. It is 16.0. So, I'm going to put 16.0 down there. I'm doing this part relatively quick. Alright, because we've already done this in the last video. So 40 divided by 12 times 1, and we get 3.33 moles of carbon. This one's going to give us 6.7 moles of hydrogen. Multiply 1, divide by 1. And the last one, we get 53.3 divided by 16. It's going to give us 3.33 moles of oxygen. Alright, remember that was step 2. In step 3, we now divide by the lowest number here. So my lowest number is 3.33, so everything's going to get divided by that. We are hoping for whole numbers here. If they are, we'll almost be done. Alright, that divided by itself is going to give you 1. Same thing here. Take your calculator, 6.7 divided by 3.33, and it gives you about 2. These are whole numbers now, so my empirical formula is CH2O. And here's my empirical formula. Alright, so this is what we learned last time. Now what I want to do is go to my molecular formula. There's not many steps left for this to find the molecular. It's pretty simple. So, what I want to do now is get the molar mass of my empirical formula. Okay, I want to get the empirical mass here. And how do we do that? Well, I have 1 carbon, so carbon is 12.0 grams on the periodic table, and I have 1 of them. I've got hydrogen's 1.0 grams on the periodic table, and there's 2 of those, so I'm going to multiply by 2. And there's only 1 oxygen, so that's 16. Okay, so I've got 12, 2, and 16 grams. I'm then going to add these up. Okay, so when I add these up, I get 2, and that's going to be 0, carry the 1, and I get 30.0. And what this is this is actually the molar mass, so it's not just grams. I guess I should put this. This is grams per mole. Alright, so I got grams per mole. So this is the empirical, And right here in the problem, they have to give you the molecular. And if they do that, what we do is we take our molecular mass. This is given straight from the problem, and divided by our empirical mass, okay? So again, this is your molecular, and this is your empirical. Oops, I'm writing on the black there, sorry. And divide them. This is going to give you approximately a whole number. It's going to do it every time. It's going to give you approximately a whole number if you're doing it correctly. So I'm going to take 180.18 divided by 30, and this gives me approximately 6. So how you find your molecular formula is you take the formula you have for empirical, and this 6 is going to multiply by all the subscripts. So this is subscripts 1, so C6, so 6 times 1 is 6. H12, because 6 times 2 is 12. O2, because 6 times, I'm sorry, O6, what am I doing? O6. Because 6 times 1 is 6. So this is my molecular formula, C6, H12, O6. So empirical is here. Once again, to find your molecular, you do the molar mass of your empirical. You have your molar mass of your molecular, and you take the molecular divided by empirical, it should give you a whole number. Take that number and multiply it, a little multiplication symbol there, times the empirical formula, and you'll get your molecular. Let's try another one. Okay, we're going to do the same thing here. It gives us the percentages, and it gave us our overall molar mass. So I've got hydrogen at 5.93 grams. So this is hydrogen. I've got my oxygen here at 94.07 grams. I'm going to take grams and convert them to moles for both of these. Oops, that's oxygen. All right, grams and moles together. My moles 1. We find my grams from the periodic table. For hydrogen, it's 1.0. All right, for oxygen, same thing. That's 1. Periodic table for oxygen is 16.0 for the grams. Let's plug this into our calculator. I get 5.93. I don't know why I'm dividing by 1 and multiplying. It's the same number. 5.93 moles of hydrogen. And then do the 94.07 divided by 16. And we get 5.88 moles of oxygen. All right, let's go in here and divide by our lowest number, which is 5.88. All right, and for both of these, I get approximately 1. So my empirical formula is HO. Okay, my empirical formula. All right, to find the molecular formula, once again, I need the mass of this, my empirical formula. So hydrogen is 1.0 grams per mole in the periodic table. Oxygen is 16.0 grams per mole in the periodic table. There's 1 of each. So keep those, add them up, we get 17.0 grams per mole. We now do the molecular formula, or I'm sorry, molecular molar mass of 34 grams per mole, divided by our empirical molar mass of 17.0 grams per mole, and we should get a nice whole number here, or pretty close to it. On this one we get a nice whole number of 2. Take this and multiply it times your empirical formula, the subscripts that are there, and we're going to get, when we multiply this, H2O2, better known as hydrogen peroxide, H2O2. So this is our molecular formula, empirical and then molecular. All right, one less problem to do here. This is a fun one, tryptophan. That's the chemical that's in turkey that people say makes you sleepy. There's actually not enough tryptophan in the turkey to actually make you sleepy, but people think it does. All right. And it gives us this empirical formula, and then it signs find the molecular formula. Now, you'll notice here that they don't give you percentages. They've actually done a really, really nice thing to you here. they gave you the empirical formula. And sorry, the subscripts are missing here. That should be C11H12N2O2. Well, if you remember with when we get the percentages, our whole point is to get the empirical formula, and they gave it to us. They also gave us the molecular formula's mass. So all we need to do, we need to find the molar mass of the empirical formula here. So carbon on the periodic table is 12.0 grams per mole. There's 11 of them, so times 11. In just a second we'll do that. Hydrogen on the periodic table is 1.0 grams per mole. Alright, and there's 12 hydrogens. Nitrogen on the periodic table is 14.0 grams per mole. There's 2 nitrogens. And then oxygen on the periodic table is 16.0 grams per mole. And we have 2 oxygens. So let's put these in our calculator. 12 times 11 is going to give us a nice number of 132.0 grams per mole. 12 times 1 is going to give us 12 grams per mole here. Alright, 14 times 2 is going to give us 28.0 grams per mole. And then 16 times 2 is going to give us 32.0 grams per mole. We now just add those up. Alright, sorry the video messed up. We're restarting here. So I had, these is my molar masses once I multiplied. When I add these together, I get 204.0 grams per mole. Alright, so this is my empirical molar mass. So if you remember, we take our molecular mass they give us, 204.25 grams per mole, divided by our empirical molar mass. Alright, and they should give us approximately a whole number. This number comes out to be 1. What does this mean? Well, this C11H12N2O2 is not only the empirical formula, but if you multiply by 1, this is actually also your molecular formula, and that can happen. So tryptophan's real formula is C11H12N2O2. Can't be reduced anymore, so this is also your empirical formula. And that's how you do molecular formulas.